Good morning, students. Today's topic is dinitrogen, and we are going to discuss about the preparation, properties and uses of dinitrogen. First is preparation, and first method, commercial method. Commercial method. How can we prepare? Commercial. That is liquefaction and fractional distillation of air gives liquid nitrogen at a boiling point of about 77.2 Kelvin. First it distills out, leaving behind oxygen at a boiling point of 90 Kelvin. Okay. Liquefaction and fractional distillation of air gives liquid nitrogen. Okay. Liquid nitrogen is obtained at a temperature of 77.2 Kelvin. First it distills out, leaving behind oxygen, and its boiling point is 90 Kelvin. Okay. Here the boiling point is 77.2 Kelvin. First liquid nitrogen distills out, then oxygen is obtained at a boiling point of 90 Kelvin. Okay. Next, second is laboratory method. Laboratory method. Here it can be obtained from ammonium chloride and sodium nitrate. Ammonium chloride reaction with sodium nitrate. Okay. Liquid nitrogen is obtained. Nitrogen gas is obtained. Then H2O and then sodium chloride. Okay. In this reaction, small amount of impurities are obtained. That is, impurities are NO, that is nitrogen oxide, and HNO3, nitric acid, are obtained. Okay. This can be removed by passing the gas through aqueous sulfuric acid, H2SO4, containing K2Cr2O7, that is potassium dichromate. Which can be removed by passing the gas through aqueous H2SO4 containing potassium dichromate. Okay. This is the laboratory method. Okay. Third method, by a thermal decomposition of ammonium dichromate. Thermal decomposition of ammonium dichromate. Okay. Ammonium dichromate on heating gives nitrogen, then H2O and Cr2O3. Nitrogen is obtained, then Cr2O3. This is the reaction. Next, it can also be obtained, very pure nitrogen can be obtained by the thermal decomposition of sodium or barium acide. Okay. Pure nitrogen obtained by thermal decomposition of barium acide. Okay, barium or sodium acide. Okay. Acid is N3, that is BaN3 twice. On thermal decomposition gives barium and 3N2. This is the reaction. Okay, these are the different preparation of dinitrogen. Next, properties. Properties is a colorless, odorless and tasteless non-toxic gas. Colorless, odorless, tasteless, non-toxic gas. Okay, and it has two stable isotopes. Two stable isotopes. Which are they? Two stable isotopes, N14 and N15. Okay. Next, it has very low solubility in water. Low solubility in water. That is only 23.2 cubic centimeter per liter of water at 273 Kelvin and 1 bar atmospheric pressure. That is 23.2 cubic centimeter of water only dissolved. Okay, water per liter of water, only this much cubic centimeter per liter of water at 1 atmospheric pressure, 1 bar pressure. Okay, 1 bar pressure and 273 Kelvin. Standard temperature and pressure only 23.2 cubic centimeter per liter of water. So it has very high, low solubility. Okay, and low freezing and boiling point. Low freezing and boiling point. Okay. Next, dinitrogen is inert at room temperature. Okay, because it contains N triple bond N. This is the shortest bond and strongest bond. So it has very high bond enthalpy. So it is inert at room temperature, but its reactivity can be increased with increase in temperature. Okay, dinitrogen is inert at room temperature because it contains N triple bond N bond. It has high bond enthalpy. High bond enthalpy. Okay. Okay. So inert at room temperature, but with increase in temperature, its reactivity increases. Okay, this is the next point. Reactivity increases. Now, it directly combines with some metals to form ionic nitrides. Okay. Combines with some metals and form ionic nitrides. Example, lithium, magnesium, it reacts. Lithium with lithium, it gives lithium nitride. Okay. Then with magnesium, it gives magnesium nitride. So ionic nitrides are obtained. Next, it combines with hydrogen at a temperature of about 773 Kelvin in presence of catalyst, that is Haber's process. Ammonia is obtained by Haber's process, that is nitrogen on reaction with the hydrogen. In presence of a catalyst, it forms ammonia. Next method is Haber's process. Haber's process. With nitrogen with hydrogen. Okay, with hydrogen at 773 Kelvin in presence of a catalyst. In presence of a catalyst, ammonia is obtained. Okay, ammonia, that is N2 plus 3H2. N2 plus 3H2 gives 2NH3, 773 Kelvin. Okay. And during this, energy is released, that is minus 46.1 kilojoule per mole. Okay. That is a reversible process, and this much energy is released during this process and ammonia can be obtained. Okay. Next, at a very high temperature, that is about 2000 Kelvin, nitrogen and oxygen reacts and form nitrogen oxide, NO, N2 gas on reaction with oxygen at a temperature of 2000 Kelvin. At a very high temperature, it can be obtained. Okay, 2NO. These are the different properties of dinitrogen. Next, uses of dinitrogen. Uses. First use, used for the manufacture of ammonia. Manufacture of ammonia. Then, it can also be used for the manufacture of other chemicals containing nitrogen and other chemicals containing nitrogen. Example, cyanamide. Okay, first use. Then it can be used for inert atmosphere required. Used for inert atmosphere. Required. That is in iron and steel industry. Inert diluent for reactive chemicals. That is, it is used in iron and steel industry. Okay. Second use. Used in inert atmosphere, iron and steel industry. Okay. Next point. Liquid nitrogen is used as a refrigerant to preserve biological materials, food items, and in cryosurgery. Okay. Liquid nitrogen is used as a refrigerant. To preserve biological materials. Then cryosurgery. And in food items also. Okay. And food items also. So it is used as a refrigerant to preserve biological materials, food items, and in cryosurgery. It is used in cryosurgery. Okay. These are the different uses.